Hi, uh, hi, welcome everyone. Welcome to our demo class, the Java course. We at CodeCraft offer a course in Java and web development. So this class gives you a brief sort of sneak peek into how we teach and what the topics we cover. So before we get started, I would like to talk a little bit about CodeCraft. My name is Avnish and I'm the founder of CodeCraft. CodeCraft was founded about a month ago. And the primary reason I founded this company was essentially bridge the gap between what is being taught in colleges and what the industry needs. There are a lot of colleges generally tend to focus more on the fundamental principles, whereas industry is looking for people with applied skills. Some of these skills are sort of barely touched at the college level, and some of them are not at all covered various college courses. And also we're also focusing not just on your college courses, but there are a lot of advanced frameworks, tools and technologies which are just designed for the industry. If there are industry professionals, people sort of become aware of these technologies, we provide courses to help you learn those technologies. So we focus primarily on industry relevant skills, things, the software, the frameworks which are currently in use in the industry. Another thing that we focus on in our classes is that uh, we focus a lot on hands-on assignments and doing mini projects. So roughly for every hour of lecture we end up doing at least an hour of lab, which sort of gets you familiar with the concepts that we have covered in that lecture. Uh, each of the students get a virtual machine into which all the prerequisite software is installed, and you guys code on that machine, and so you're able to see your code in action. Uh, I've got Professor Amit Kumar from IIT Delhi, who's on our advisory board, and Dr. Sumit Sopti, who's a PhD from Princeton University. He's also on our advisory board. They both help with the course design. Let's talk about Java. So Java is both a programming language as well as a platform. Um, when we say Java as a platform, what we mean by that is it sort of provides you a very good foundation on top of which you can build various applications. We'll see in some future slides, in a few slides, what does the platform include. But to start with, to run any Java program, what you need is a runtime environment. It's often called a JRE, Java Runtime Environment. And if somebody gives you a Java program, then in order to run it, you need to have this. Whereas, let's say if you want to create a Java program, uh, you need something additional. I mean, just the runtime environment will not let you create a program. So the first thing that you'll need is, if you're creating a program, is you'll need a compiler, right? Then if you have created the program, you also need to test it and run it. So definitely we'll need the JRE. So this whole thing is packaged in a software package known as JDK, or Java Development Kit, and which consists of the JRE, the compiler, and certain other dev tools which are needed during the time of development. Right. So these are the two terms that you might have heard of often when you would have heard of Java, right? So let's look at some of the features of Java. What made Java very popular? So one thing that Java provides is that it provides automatic memory management, uh, which means that there are no pointers. The system takes care of 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 reclaiming unused memory when nothing is pointing to it, right? This simplifies programming a lot, because programming with pointers is difficult and it's error prone. Other thing which made Java really famous was that it was like compile once and run anywhere kind of language, which means that once you have compiled Java on one platform, let's say Linux, the same program is going to run as is on Windows, to run as is on a Mac. So that's a big advantage. You don't have to keep separate code bases, one for Windows, one for Linux, one for Mac. So that also was something which really made Java very popular. Java supports the object-oriented programming style. Object-oriented programming style is a very useful style of programming which essentially you know makes it easy to manage complexity. As programs become large, they become complex, and if you're not careful in managing that complexity, programs can become very they can have a lot of bugs. They can break in unknown ways. So object-oriented programming is a style which helps us manage the code much better. Okay. We will get into the details of object-oriented programming in a couple of slides. A lot of our lecture is going to focus on object-oriented programming, and we'll see, like, how the concepts of object-oriented programming are implemented in Java. Uh, so apart from all this, Java has a large ecosystem. What do we mean by that? That it is a large ecosystem. Explain that. Let's move to. Essentially, when we say Java's ecosystem is large, we essentially mean that Java is sort of omnipresent. It's present on your mobile phones, it's present on your desktop, it's present on your server. If you want to create applications on any of these three types of devices, can use Java to create those applications. So for example, like if you want to build a dynamic website, you can use a web application server. Typical examples of web application server that are in the market are Tomcat, JBoss, WebSphere. If you want to, these days data science is becoming a very popular field, and a lot of data analytics and big data work is happening. Hadoop and Spark both are built on top of Java. It's present for data analytics. Pentaho BI is another business intelligence solution is built on top of Java. Mobile, if you want to write a mobile app for Android, write it in Java. If you're creating a desktop app, something like a Word, Excel, or something that is going to run on a desktop, right? It has an icon on the desktop, you double click it, UI opens up. So Java has support for that as well. In fact, like the IDE, the integrated development environment called Eclipse that we'll be using for most of this course is written in Java itself. Sometimes a large ecosystem can make Java a bit daunting language because there's so many other things that go with it that one has to learn. But I think if you plan carefully and you slowly pick up the language, slowly incrementally add on different type of platform, a career in Java can be very rewarding. So now let's talk about object-oriented programming. Okay, what is object-oriented programming? Fundamentally, object-oriented programming is a way of expressing the logic of your program as objects that interact with each other. So typically an object is modeled after a real world object. So let's take an example of what a real world object is. Let's consider this room. I mean, there's a fan in this room. Fan is a real world object. How would you describe the fan? We can say that a fan can be described by the number of blades that it has. A fan can be described by what its current state is, whether it's turned on or it's turned off. So these are the attributes that are describing an object, which are typically nouns or adjectives which define the state of an object. Apart from a state, an object can also have behavior. So for example, we can say turn on a fan, to turn off a fan, right? This is essentially the behavior that a fan object exhibits, that it can be turned on, it can be turned off, and turn again is a verb, right? You can increase the speed of the fan, you can decrease the speed of the fan. Again, increase, decrease is a verb. So an object has a state, and it can also have some behavior that it can exhibit, right? A lot of times, when you create an object-oriented program, you have a lot of these objects living inside that program, and one object can have a handle to another object. By having a handle to another object, essentially we means that one object knows about another object, and if it wants, it can see what its state is, and it can invoke some behavior on it. So for example, we are, let's say, in a room. Room is another object, and room can see how many fans it has. It can see whether the fan is on or off. A room can know, room can instruct a fan to turn itself off. So this sort of defines an object state and behavior. So before we move further, so let's look at this example in code. I mean, what does it mean to represent a fan in a code? Right? Before we do that, let's cover one more slide. I think it will illustrate the concept of a class, which is kind of important before we get into the code. So essentially, when many objects they look similar, it is natural to classify them into a group or a type, right? So let's say in this fan we have got six. In this room we have got 6 fans, and all of these fans are pretty much the same, but they are actually different. I mean, they're of the same type, but they're different. So essentially, when you group similar objects in a category, we can think of that as a class. So there is a class called fan, and then you can create multiple objects which each represents a different fan. So class can be thought of as a blueprint of an object, and it can be used to create those objects. Okay? So class is essentially a definition of an object, what attributes an object can have, and what kind of behavior it can exhibit. Anytime we define a behavior for an object, typically it will modify the state of that object. Example, like in the example of a fan, when you say increase speed, let's say we want to increase the speed of the fan by 1. Its current state had a speed of 2. Then after you invoke that behavior on the object, its speed will become 3. So let's get into the code and let's see how they're represented. So let's open the VM. To the VM in, and so here I've got Eclipse running. Okay. So the first thing that we'll do is we'll try to create simple class. Call it fan. Okay. Leave everything else as default. Finish. So now we have got a class that is created. The class is called fan. Now class is a blueprint of an object. Now what attributes do all fans have? Well, we can think of one is number of blades. We define that as an attribute. Other thing that every fan has, we call it the state. And state can either be on or off. Okay. Representing state using a string is not the best thing to do. We should ideally use an enum, but for our class, to keep things simple, we'll just define that the string, and it can either be on or it can be off. So let's say we define a constructor now for this fan, and let's say constructor just takes how many blades the fan has. Okay, define that. Blades parameter that was. This will create our object. Okay. Now let's talk about what kind of behavior it can have. The most basic behavior is can turn itself on. Define a method turn on, and what this should do is this should set the state to on. Let's say by default we'll give a default value to state that whenever you create a fan, it should have, right? So that's the default value. It turns itself on, the state is set to on. Similarly, define behavior or method called turn off. Turn off means set the state to, okay, this turns the fan off. This is a very basic example, right? Other behavior that we talked about was, let's say, if you want to increase the speed of the fan. Okay. For increasing the speed, we can say, let's say, if speed, let's say it's a fan that has a maximum speed of 5. If the speed is less than 5, then we can say that you increase the speed whatever its value earlier was. So this, okay, right now it's running out because we should add one more state, let's say, to the fan. Okay, right. So that's the speed of the fan, and then you can increase it. By default, let's say it a value. So now we have give it. So this is a simple fan, right? Similarly, we can write decrease speed. But let's take example of another thing is to let's say it's tube light. Like how would you represent a tube light or a bulb in the room, right? Let's take example of a let's say we'll create a class called bulb, and what are the things that a bulb has? Well, has a state whether it's on or off. That default of off. And another thing that a bulb can have is, let's call it wattage. How many watts bulb is. So now again, a bulb can turn itself on or off. The same thing. So let's just copy some of this. Turn a bulb on and off. It also has the same thing. Is this? This is the behavior of a bulb. So we can save this. Another thing you can think of, like a television, for example. That could also. What kind of behavior television has? Let's create the class television. Now we have this. So again, television can also be turned on and off. So it has to have a state. Other things such what else is there in a television? I guess the channel that's currently on. You can say the int channel is the channel number that's currently on the TV. And another thing, common thing, is the volume. Define volume. Current video volume. Same thing again. I mean, a television needs to be turned on and off, so you have to have that behavior there. Apart from this, what else can a TV do? A TV can essentially, you can increase its volume, you can change its channel, right? Let's say we define like public channel up, which means that its channel is going to go one up. It's like pressing the channel up key on a remote. Say this dot channel equal to something like this could be. Say by default we give, let's say TV has a volume of 5, which level channel is, can have this. Okay. Now one thing you would have noticed, what has happened in this while we are coding this, is we have been doing a lot of turn on, turn off is being copied over from every, like from fan it got copied to bulb, from bulb it got copied to television. Essentially, because all of these things, fan, bulb, television, they're objects which exhibit similar behavior, which means it can be turned on and it can be turned off. Now, when you see this kind of thing happening, uh, it makes common sense that all of these have this common behavior, and this common behavior is common to what things? I think turning something on and off is a very common behavior for an electrical appliance, right? So here we see that, as we look at these three concrete classes, fan, bulb, television, we see that that there is certain behavior in these classes which is common across the three, and which is turning itself on and off. So it becomes natural to sort of abstract these things out into what we call as a common class. We can think of it as an electrical appliance, right? And maybe an electrical appliance can be thought of a thing can turn itself on or off. And you can think of that fan is an electrical appliance, bulb is also an electrical appliance, and so is a television. So how does object-oriented programming embodies this concept, right? This is known as the concept of inheritance, where you look at certain concrete objects and then you build higher level objects from there, because all of these concrete objects exhibit a common behavior, and we refactor that common behavior out into a new class. I'll show you how that is done. So we will define a new class called, say, an electrical appliance. An electrical. Now, what kind of behavior does an electrical appliance show? Essentially, it can be turned off and on. Public turn on. Then you can think of. Now these things do the same thing. When you call turn on, the electrical appliance turns itself on. So what we can have here is the state is of an electrical appliance. The state is not specific to fan, bulb, or television, but it's the state of the electrical appliance, whether it's on or off. You can define that here. State on or off. Okay. Set to off, turn it on, to off. So now that you've defined your electrical appliance, fan, bulb, and television don't need to have this stuff repeated, turn itself on. So we can remove all of this. Lines we can remove. We can remove this line and instead say that fan sends electrical appliance. So this class will now behave in exactly the same manner that it was behaving earlier. Even though it does not have a method called turn on and turn off, but it is inheriting that method from its parent class, which is electrical appliance. Okay. Now similarly, we can do the same thing to bulb and television. It doesn't need these two functions. Doesn't even need this guy, because all of this it can get it from code that we have written, electrical appliance. And same thing we'll do for television. Essentially, as you see, like what has happened with inheritance, what we have done is we have done away with the repeated code that was present in every electrical appliance that we had, and instead we have reused the code in these classes, television, bulb, and fan, from the code that was present in electrical appliance. This code, it will be sort of get reused. We'll see how it gets reused. Before we go that, one of the other important concepts in object-oriented programming is that of data encapsulation or information hiding. Typically, if somebody has reference to a fan object, they should not be able to get to its state directly. Essentially, it's a bad idea. If you expose Ideally, objects should be exposing their state through specified methods only, so that nobody has direct control to change the state, but the class itself defines how the state of an object of that class can be modified, right? For example, here we have left things as so how do you achieve that actually? So the way to achieve that, I would say, would be to put a keyword called private. What this means is that this data will not be accessible to any code outside of this class. So if some object has reference to it, by default that object will be defined in another class, and that object will not have access to these variables because we have made them private. If you have to modify the speed of this, you cannot go directly get a reference to a fan and say fan.speed is equal to 5. That is not permissible. If you have to increase the speed of the object, you call this method called increase speed on that fan object. Now, essentially, I mean, you could argue that you could do it both ways, and yes, it can be done both ways. But when programs get larger, having control on your own code, like if it's one person who's doing everything, that's fine. But any large software program or any software program which is sort of running in a company would definitely would be worked upon by multiple people, and you can if you don't allow such kind of information hiding, a lot of bugs can creep in because everybody has access to data of everybody. And while everybody has good intentions, sometimes they use that data and make modifications to the state of an object in a way that is harmful to the whole program. So essentially, through this data encapsulation or information hiding, we prevent such things. Let's save it. Okay. Now we have got these four classes. So we have seen data encapsulation. We've seen how inheritance happens, right? Now let's look into, we'll get into another important concept known as polymorphism. Let's see how that works, right? So that, let me let me create another object or another class called room. So let's say we have created a room, and for the sake of this class, let's define that room can have a bunch of electrical appliances, right? We will define that the room contains a list of electrical appliances. Okay. And that's a array list type use of electrical appliance. This creates an empty list of electrical appliances, and as you so let's say, what kind of operations can the room expose? The room can expose an operation called, let's say, add appliance. Add appliance anything, but it adds whatever electrical appliance you are passing to it. Call that, adds it to that list. Okay, is dot appliances add, we pass to it whatever was passed. So this builds up the list. Let's say a room can have another method, say like turn all appliances. Okay. So also just turns all the appliances, doesn't return. So once this has been done, what we want to do is, in this case, we want to iterate through each of these elements in the list. So you can say for in list of appliances that we have, what do you want to do with it? we want to essentially turn them on. Dot. I'm missing. Dot. Turn it. And in the room get turned on. Okay. So this is a simple thing that will turn on all the appliances. Now, to execute this program, static void main, that way to book program. I guess you here we are gonna first create a bunch of objects, then we are gonna add them to the room, and then finally we'll turn those appliances on, right? Let's say first we create r is equal, then we create, let's say, for that we create another one, get a bulb, so we'll create a bulb. After that we'll create a now we'll add each of these, add appliance, okay, so let's just check if we have. The reason it's happening is because we forgot to add this tens electrical appliance. Wait, then that program should not fine. Then we add the second appliance. We add it to the bus. Called it that. And then finally we add the fan. This adds all the appliances, and then let's say we say that room turn all the appliances. Now what happens when all the appliances are turned on, right? So we see that turn on is defined only here, right? Now it will invoke this method whenever we are calling this function. To see that this method is getting invoked, let's write a small print statement. Let's say you want to see what type of object we are turning on. So there's a very simple function there. Dot get class dot get name of the class or name of the type of the object that is getting turned on. Now we have this. Let's say we run this program. Okay, we run this program. Let's see what happens. Run this. There it is. You see the output in the console. Turning on television, turning on bulb, turning on fan. Now you can see we had a spelling mistake here. Turn in on that. So we see that this method is being invoked. Now let's take a look also. So let's say when we turn on a fan, we want to give it, when we turn a fan on, we want it to have a default speed of 1. I mean, we're not happy with the speed of 0. How could you achieve it, right? So one way to achieve that would be to to say that the turn on behavior of this guy is different than the turn on behavior of a regular electrical appliance. Right? A regular electrical appliance just switches the state to on. So what we will do is we will define this method again here. This stuff that we're doing right now, this is known as overriding, which means that a child class is overriding the behavior of a parent class. So in this relationship, I mean, electrical appliance is considered the parent class and fan is considered the child class. And fan is extending, a child class is inheriting the behavior of the parent. Okay? Parent classes are also known as super classes. So when we turn it on, what do we want to happen? State should still be on. So to achieve that, we call the super classes turn on method, and say additionally this dot set it to 1. This is what happens when a fan is turned. Here what we have seen is that how you can override the behavior in a child class. Don't have you get the behavior by default. You want to change that behavior, you can override that method, write code in it which will let you essentially give it a new behavior. Now we have given it a new behavior. Now so let's see how this works, right? So this tied with this whole overriding behavior is another behavior which is also known as polymorphism. So essentially, if you look at our room, right, our room has a bunch of electrical appliances, and electrical appliance is a superclass, and it can have any object, can point to any object which is type is an electrical appliance. But when we are invoking the method turn on, we are invoking it on electrical appliance, right? But it doesn't mean that this method will be invoked always. Okay? It really depends whether a child class has a method by the same name. If it has, then it will end up invoking that. So this is known as polymorphism, where something of type electrical appliance, when you at one point of time this variable will act like a fan, other point of time it might act like a bulb, and another point of time this variable may act like a television. It really depends on what its concrete type is. So this behavior is, so here we are not writing a code like we are iterating through the list of electrical appliances. We don't say we're not referring anywhere to fan, a bulb, or we're not saying something like if E is an instance of a fan, then you call fan.turn, right? So this is what is known as polymorph. If we run this program now, made the change, we have added the fan object. We have not yet. So let's, to make sure that it's actually this method that's getting called, we'll add setting this. Make sure that this guy was called. So now let's run the program. Turning on television, turning on bulb, turning on fan, and then it says setting the speed of fan, which means that it was other method that was called. Okay. So this kind of, I hope, gives you an idea of object-oriented programming, what is inheritance, what is data hiding, encapsulation. Let's do a quick recap of the things that we have learned. So child classes don't just inherit the behavior, they can also override the behavior. That's what we just created a fan and overrode the turn on behavior. Polymorphism is the concept where an object can take many forms, or a variable of a certain type can refer to different concrete objects. That's known as polymorphism. If you have a variable which was of type electrical appliance, it can point to a fan, a bulb, or tube light. And when you invoke any behavior on that particular variable x, it invokes the right method of the child. Okay. Okay, so I think that brings us to to an end to this part of the class. Let's take a quick 5-minute break, and after that we will get into web programming, how Java is being used for the web. Hi, so guys, welcome back. Break. So now we're going to talk about web programming discussed on the agenda. So we already covered object-oriented programming. Stuff that we're going to talk about is how do you create dynamic websites. If you look at web programming, the primary job of a web server is to generate HTML page. The client is the browser, typically makes a request to the web server, and in response, web server generates some HTML. So that's the primary responsibility of a server. Now, server receives a request, returns HTML in response. So typically in the Java world, these requests are actually handled by small of code known as a servlet, and its primary responsibility is generate the HTML. Now this is a very small piece of code that you end up writing, but since this piece of code is written inside a server which takes care of the rest of the things, you don't have to worry about it. But what you have to always remember is that the servlet that you are writing is running inside a container, and that container is providing a lot of services to your servlet. So container, for example, provides the handling of the network connection, it keeps listening on a port, it closes the connection, and various other things. For example, if you want to manage database connections, you manage those and various other things. So a good example of a container that's very popular and is open source is Tomcat. Okay. So before we go any further, let's try to analyze a small web page. Okay. So let me go in to a web browser, and here what I'm showing you is my school's homepage, right? So what we will do is, in order to analyze this page a little bit, like what HTML looks like, what a page is composed of, we will enable the developer tools in. So here I enable the developer tools, and I want to focus on the network tab. Essentially, this tells us like what happens when you request a page on the web. So let's say do this, and now a lot of requests have been made, and you can see these requests in here. Okay. Now there are lots of different types of requests that actually sort of go on when when a web page is hit. The most important request that happens is the first request, which is shown here in this particular. Here we made a get request. See that the method was get, and in response to this request, our server returned a lot of HTML. Now see that. Now you can see that this is the document or the HTML that was sent back by the server. So there was some code on the server side that we had which generated this whole huge. And then often in this piece of HTML, you would see references to style sheets, images, and JavaScript files. In this HTML, there is a reference to some style sheets. These files are called style sheets. And the style sheets generally give style to the page. I mean, they control things like fonts, colors, where you want to place things. And then if you see that there is some JavaScript as well that we download. Typically a lot of JavaScript comes at the bottom of the page. So for example, for this request, so we see that there was one request which brought this whole HTML page. And after that, there was a request to bootstrap min.css, which brought the CSS file because the HTML page was referring to the CSS. There are a bunch of CSS files that this page needed. So browser made further requests to those CSS. Then the page was referring to certain images, and those images got downloaded successively, right? So this is how typically a web page is built. That you get the raw HTML from the server, and then that HTML may refer to other style sheets, JavaScript files, and then browser makes further calls to those to fetch those assets. Okay? Now, how are you going to generate this kind of HTML from the server? Right? That's what the whole web programming is about. Large chunk of web programming essentially revolves around how do we compose that HTML. So as we have discussed we have seen in our previous slides that Java exposes something called a servlet to let you do this. Okay. Now, so how do you actually create these servlets? So if you use the Eclipse IDE, Eclipse IDE has simplified a lot of things for you, and with very little setup, you can have a small website going for you in less than 10-15 minutes. So we'll try to do that today and see how do you build a very simple website. I mean, it could be a very simple basic one with hello world kind of out, but we'll see what is involved in setting that up. So so continuing further on our presentation, so server will typically receive a request, and based on certain rules it will invoke a servlet whose responsibility is to render the response to the client, right? So what are these certain rules that we're talking about? Well, rules typically take the form of that if the request is to this URL, right? Or if there is something in the URL path, for example, slash hello slash XYZ, then you invoke a certain servlet. So this is a rule that can say that, okay, this servlet has to be invoked when the request is of a certain type. So apart from that, a single server can host multiple unrelated applications together. So that's a big advantage of putting together a web application server, is that you can not just have one application running on it. You can have multiple applications that can be running inside that server. I can have my the website that I showed, I could have that running inside that server. Somebody else's website could also be running inside the same server, and it's the server software which sort of guarantees the isolation of these applications. They never mess with each other. So one application cannot sabotage some other application. So this is a feature that these application servers provide, right? Now, so since we rely on the server software to process these requests for us, what do you give to the server software? So what is given to the server software is typically what is called as a web application archive. And web application archive primarily consists of servlets fundamentally, but there are like various other things in there which we'll not talk about in today's class, but which we cover in our course, which essentially gives life to the web application. Okay. Now when you deploy this application to a server, right? Server wants to know certain things about the application, and you communicate with the communication between the web application and the server. Rather, the contract between the web application and the server is defined through a file known as a deployment descriptor, typically called a web.xml file. Okay, and this essentially defines like so that a server knows what application it is, where are the Java classes related to this application, what kind of URL should point to what servlets. There's a whole bunch of information that goes inside a web.xml we cannot cover in this class, since we want to focus just on the very basic web application, but we'll see one small web.xml what it looks like. Okay, before we go any further, I would like to spend a little bit of time in creating a small Java web project using Eclipse. So let's do that first. So okay. Now, okay, we have already been through this one, so I'm just going to less clutter on the screen. So you can go and create a new project. When you create a new project, the key thing is, well, okay, this is not a good thing that I did, so let me cancel this out. You have to go in and create a project, but you should other list. In this other list, you will find a web project down. Web. What we'll do is we'll create a dynamic web project. Okay. Next. Okay, you have to give a project a name. I'm just going to call it a demo web. Okay. Now a demo web app is created. Let's so let's see what it's asking us. So project location, you could choose that as the default one. Then it's asking us for a runtime. So runtime is the one which we were just talking about, right? The web application server. It's the thing or the container inside which your code is going to run. Here I'm going to choose an Apache Tomcat 7 runtime. We'll just go with the older version of the Servlet 2.4, and configuration is just choose the custom configuration. Let's hit next. Okay. It's asking us to where will all the source code files be, so we just use the default one of directory called source. Next. Then it's asking us what's the context root that we want to use and what is going to be the directory inside which we are going to place all of the content. So let's leave that as default for now, and let's hit finish. What this does is that it creates a project and it's asking you to switch your perspective to a Java EE perspective. Go ahead and say yes to that. All right. And if you see, it has created a new web app for us called the demo web app. Now this app has been created. So if you open this, you will see that there's a deployment descriptor. If you go inside web content directory, you'll find a directory known as webinf. And inside webinf, you'll find a web.xml. This descriptor that you see here is nothing but the same file, web.xml. Open web.xml, and you see that it is a very basic description of a web app. It has got a display name and then some welcome file list. Okay, so so let's not worry too much about it, but essentially it's telling the server that when this web application is deployed, let's give it a name of demo web app, and if any request comes for this application, we will just we'll serve one of these files. If the request is coming to the slash URL, we will first serve one of these files, right? And all of your web content, like if you have any HTML, CSS, and those kind of things, that typically goes inside this web content directory. So the first thing that we'll try to do is we'll try to create a servlet to handle a request. Okay. So to do that, let's go in app. I want to create a servlet. Okay. New. Then we create a servlet. Okay. So servlet is essentially a small piece of code which can handle particular web request. If a web request is coming, server will invoke the code inside the servlet. Before we go and create the servlet, actually let's quickly look at the definition of a servlet, like what servlets are. For that, let's go back to our presentation. Okay. So so essentially web is running on top of HTTP protocol, and there are two very popular requests, two very popular type of requests which form the vast majority of the web requests. These are known as the GET request and the POST. So a GET request is a request where a client is trying to get something from the server, as the name implies, and a POST request is a request where a server is trying to post, where a client is trying to post some data to a server. A GET request can also be used to post data, so that's kind of confusing, but fundamentally that's different. GET typically means that you're trying to get something from the server, and post something means that you want to send something to the server. But as a response to each of these requests, the server typically sends back some HTML as a response. If 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 a servlet is going to be handling these type of requests, uh, the creators of the servlet API decided to define two methods inside a servlet. They're known as doGet and doPost, which essentially, so if a GET request is coming to a web server or to an application server instead, it will invoke the doGet method of the servlet. If a request is coming which is post type of request, it will invoke the doPost method, right? So essentially here the container is invoking a method that you have defined in your class. The signature of the method is, as you can see here, is doGet, and it takes as an input a HTTP servlet request object, and it takes two inputs. First is the HTTP servlet request object, and the second one is the HTTP servlet response object. So the HTTP servlet request object essentially is an encapsulation or embodiment of the incoming request. We will take a look at some of the methods of the incoming request. For example, you might want to know from what IP the request might be coming. What are the various parameters that have been provided in the request? These are some of the common things that a request can export. Similarly, a servlet response object has the responsibility of writing the response back to the servlet, back to the client, right? So you will see that it exposes certain constructs can be used for writing output back to the client. So the primary responsibility of the servlet code is to write to the output stream. Output stream is exposed by the HTTP servlet response object. Servlet gets a handle to that, and it writes the HTML onto that stream. Okay. So apart from the get and post method, there are various other methods in the HTTP protocol. Like there's a put, there's a delete, there's a head method. So each of these methods is for different things. We'll know about them when we dive deep into this course. But each of these methods is sort of represented using do xxx kind of signature. Do get, do post, do head, do delete. So each of this is a different method which the container is going to invoke when it receives a request of that particular. Okay. So so now that we have understood what a servlet is, let's try to write a small servlet which will do something very basic. We'll take a look like what our objective is in this small lab. So we will see that how do we handle HTTP request using a servlet, right? And then we'll see that in action, how it works. Then second, we'll advance that a little bit by, sending an additional request parameter, and we will try to emit those parameters back in the response. That's the objective for this lab. Take us about 10 minutes to do this lab. So let's get back to our screen here. Here, I'll try to create a servlet. That's where we stopped early. Okay, creating a servlet. So let's put it inside a Java package. It's generally a better practice. So I'm just going to call that Java package Raft. The best way is to reverse your domain name. So ours is codecraft.in, so I'm just going to call it in.codecraft, and then I'm going to give it, I'll just call it, okay. And this is the class name. So by default, all servlets extend this superclass known as. So a few things happened. I don't know if you saw that behind that wizard there was something happening in web.xml. Let's see what happened in web.xml when you created a servlet. First thing inside web.xml, we defined this servlet. You remember earlier there was only this welcome file list. Now these two new things have been added to our web.xml file, which essentially is we are telling the container that I have got one servlet defined inside of this application. Its name is hello world servlet, and the code for it is in a class named this class in.codecraft.hello-world-servlet, the name of the class which contains the code for servlet named this. Other thing that it did is that created this servlet mapping. What does a servlet mapping mean? Servlet mapping is a way of mapping the incoming request to the servlet. So what we are saying here is that if a request comes to our application server with slash hello world servlet in its path, okay, so essentially somebody says that http www or something slash hello world servlet, then that particular request should be handled by the servlet named hello world servlet, and this servlet name corresponds to this class. Essentially it means that we have to write something in this class to handle that request. Now let's come to what happens inside the code of hello world servlet. As you can see that right now it has got two methods inside of it. There's do get and do post. Now what does do get and do post do? It's completely up to us. What I'm going to do is I'm going to remove this auto generated stub that was there. What I'm going to get instead is, if you want to write back to the client, you have to get hold of the response object. We have a handle too, and get the writer from there. The writer gives you a print writer object which can write to the output. So let's see, we call this guy. Put this guy. Okay, let's say to this I'll just write pw dot, it's like a system dot out, so it has the similar type. We say the world. Essentially, if a request comes at this URL slash hello world slash, if the request comes with this pattern slash hello world servlet, we will invoke that. Let's save this. Okay, now let's see how do we run this servlet. Okay, so the way to run it is go to your project, right click it, then you will get an option of run as. In there you'll have to choose as that you want to run it on a server. Okay, click on run on server. Okay, and it's asking you on which server you want to run it as. I've already defined a server for Tomcat V7, this one. Okay, now it's saying that essentially since you are running on the server, and essentially it's asking if you want to move any resources and you want to deploy some additional resources on the server. So here we have already seen that we have configured the server to run our demo web app. So let's leave this as is, hit the finish button. So this will now essentially launch the Tomcat server. You're saying it says starting synchronize, then you see a bunch of output that kind of flashed by. Okay, now your server is up and running, right? And by default it launches a page with the slash URL, okay, which you see as 404 is because we have not defined anything to handle the slash request. The request comes to slash is, so this is the name of the context name demo web app was what we chose when we created this project. So but we have, so this is going to be the base URL up till slash demo web app, that's the base URL. Now, after that, we had added something for the hello world server. Hello world servlet. After that, our servlet should get invoked. Let's hit. It does invoke our server. So here we are using a browser which is inbuilt into the IDE, but let's close. And if I open, let's say here, try to hit the same URL. Let's say if we hit post demo web app slash hello world. If I do this, it do the same. It does exactly the same thing. To make sure that it is actually invoking this servlet, make one small change here and add a few things. Hit. Okay. So now that has been saved, and what you noticed was as soon as I saved it, it restarted Tomcat. See that it restarted it. So essentially your new code is live again. So this is really good for development. Automatically restarts it as soon as you save it. This is not something that you will do in a production environment, but for development and to quickly see the results, it's a good way. Let's see what happens if I again hit the same URL. You have got the three exclamation point. The interface is different, but essentially it's getting just plain hello world as the output. Right? Now let's try a few things. Right? I don't like this slash demo web app here. If I want to have things happening just at the slash URL, that localhost colon 8080 slash hello world servlet, how would you go about doing that? So that can be achieved through known as Tomcat configuration file. So right now this is the Tomcat configuration, and if you look at its context.xml, so here you see, sorry, it's not context.xml. Yeah, so this is where it is. Essentially, if you see that Tomcat calls these applications as like text, okay, and if you see that the demo web app application, it's deployed at a path say slash demo web app. All I do is if I change path slash now, and if we resave it, if we restart Tomcat, this will essentially deploy our application at path called slash. Okay, we don't have to put that slash demo web app in our URL. So that let's stop the server, and we're going to okay, and it has started. So let's see what we can do is we can again try to remove this. It does invoke our servlet. If we have the older URL, that should fail now. This guy should fail. It does fail because there's no servlet that is mapping to that path, right? So this is, for example, how we do a simple web request. Let's make it a little tiny bit more interesting. Okay, let's say I want to pass in a request parameter, mark name. I wanted to say hello Avnish. So right now it won't do it. It says hello world, but there's a way So now that you have defined your servlet, so here we'll play with the request object. If you look at the request object, uh, request object has got method known as get parameter. The parameters that are being, let's say we get the parameter called a variable called, now you've got the name, and all we have to do is that you still get the print writer and you say hello. Let's see what happens if we change the request. Can you notice what happened? As soon as I saved this, it restarted the server and redeployed. Hit the URL again. It says hello Avnish. So now we have seen, like, quickly we have seen, like, I think it even took us 10 minutes, but how soon can you start, how quickly you can start developing web applications with Java. So here we are dealing with just plain servlets. Servlets are good from a perspective of understanding web applications, how they're built in Java, but really a lot of times uh, we will not be, like, coding to servlets. There will be, the request will be handled by some sort of a servlet, but we will be exposed certain higher level constructs like a controller that we will write to sort of handle the request. But I just wanted to give you guys sort of a quick, you know a quick peek into how you can write web application. Now you can make this very complicated by deciding what you put inside this doGet method. You could have a doGet method that will just keep creating these strings, with HTML head tag, body tag, and then you keep appending to the response, like pw.println, and you can have, like, hundreds of these statements inside a method. But that is going to make the web application very ugly. It'll work. It'll make it very difficult to work with. Still, the web app will be functional. So we will see as we go further into this course, our whole web development course in Java, is how we use frameworks like Spring, a framework like Spring, which helps us organize this code much better. Then we will look into, so this is just a plain request response. Then we will talk about how sessions are managed inside of HTTP. How do you remember users who are coming to your website, and all of those things. But for today, I think this covers my hands-on hands-on assignment, if you want to call it, to show you, like, how you can start building things and delivering things on the web. uh, Thank you very much for your time, and I hope to see some of you join our regular classes.